Hello, let me continue from where I left off in the last session. This lecture is the continuation about how to make dimensioning representations on parts which we need. As I said, there are two distinct phases or operations. One of them is the conceive a part depending on its functionality and various things. Secondly, put it down on a piece of a document, which in this cases it is easily understood by the fabricator. And something which is continued with the, why I mentioned it as two phases is, what I make a solid model, take it to the fabrication shop and discuss with them, and instead of taking to the fabrication shop, if they are directly available online or you can bring them over, you can always find out something about how to slightly modify the various features in that, such that your part can finally be fabricated, which is slightly different from production drawings. In the case of production drawings, a very complicated dimensioning, tolerancing, fit and surface finish. Afterwards, the actual other production operation, saying, if you remember yesterday I left one thing hanging, saying in case you do a non-ferrous casting, how do you remove the flash, that is wherever the molds close. For that they usually use sandblasting or shot blasting. It is a very large job, they use shot blasting. If it is a little finer job, they use sandblasting. Otherwise, for very fine parts, there is something called liquid honing or vapor blast. That is, you have pumice powder directly injected at impinging on a surface, which will improve various things, which is extensively used in tooling. When you are making tooling, this so called vapor blast or liquid honing is used. We will ignore that. The idea is saying you need to mention what is the surface finish of the part. So, one is the basic dimensions we require, second the amount of tolerances that are possible, and you also make a fit, a limits and fit, such that we know the matching part, how well it assembles to each other, and finally the sort of surface roughness and any other protective finish we give. Usually we apply either zinc or nickel plating to most parts. Earlier they used to make cadmium, but because of the environmental hazard, except in very critical applications, most of the times we use zinc or occasionally nickel, and of course all other finishes are possible. So, the drawing contains all this other than the basic dimensions, and later on the stock material from which we make the drawing are all mentioned here. The starting point of all this is something which you need to conceive in your mind. I belong to the old trained school, so I can only do things like that. So, if you see here, I have three features. On the top left is one view of the part, which I shall call elevation. At the, it is about the middle left, you see the plan view of it. Similarly, top right, you see the another side view of it, that is the left view is projected on top, and most important is at the bottom things related to the material are written there, saying, it says I need to take a 50 mm into 50 mm mild steel square of length of 36 millimeters, though the object length is only 34, that 36 mm is supposed to be specified, so that they can order stock based on this. This important right side bottom information is very much important for the bill of materials preparation. So, bill of materials has, sometimes it is auto generated, saying if in my electric vehicle we have 4 jacks and 4 corners, and then we require 4 of these bushes. So, person who is preparing the process sheet and person who is preparing the different types of these orders for the stores, he will multiply all these things, and usually if it is made in a proper format, all this is kept somewhere, it is archived and kept there, and the next person who is ordering all this, the logistics people will know what material is required and all that, and a huge amount of database is maintained about what materials are available, how much is used, how much is issued, is it a surplus material, and how to dispose it of and all that. So, all the information is coded into this. It looks simple on the outside, but reality is the part I want and how it is to be manufactured, to what tolerances it is to be manufactured, how well it has to be inspected. Finally, things are not which are mentioned here is saying typically what is the weight of the part and what is the minimum various types of quality inspections on that, that is an acceptable quality level. In case of this large gross crude part, things are not very, it is not a big issue, but imagine you have to make small pins which are part of a connector, or imagine you have small riveted standoffs and all which are part of your equipment. There, in that case, this becomes very, very important. You must choose things are which are already available and alternate supplies and all are there. Now, see here, just like me, they have indicated everything on their own, and here something related to the title block in which the type of materials that are required and everything is also mentioned here, and this probably forms part of the various assembly drawings and so on. Now, let me continue with this, which is taken from the Drexel University in the United States. This one of the probably the oldest colleges, and we were all influenced by such presentations. Now, this being on the what do you call, I hereby acknowledge that this is not my effort and it belongs to this Drexel University, the Department of Mechanical Engineering, and everybody has to undergo this. It is nothing to do with whether it is meant for the only for your examination. So, let me quickly go through things which are presented here. Can you see here? First of all, it is about guidelines for good dimensioning and engineering drawings which you need to learn. That last point, dimensioning in AutoCAD, was because previously this Autodesk's main program used to be the de facto standard in converting 2D drafting into files. And in fact, they are one of the earliest people, Autodesk were probably one of the earlier people who started with the IGES, initial graphic exchange format. Later on, the DWG format as adopted by AutoCAD became a de facto standard, and later on something related to that has become the in and out, how do you export and how do you import those things. So, several other DXF drawing interchange formats and all were standardized later. So, if you remember, we saw some of these yesterday, saying what is a basic dimension value, what is a dimension, various things are, how do you describe a particular line. In this case, we have a center line which is a dash dotted line, and on the other side no, we have things like these line lengths. Then we have, you see here some very important thing, 1 2.5 is put in brackets saying it is only a reference dimension. The idea of a reference dimension is no further machining needs to be carried out to maintain the dimension. Probably it is brought from the stock material, and after you, if you maintain this R 1.25 all around and you make these things asymptotic, by definition this will become 2.5, and one should not constrain this as well as this unless it is very, very critical. Next one talks about the basic units of measure. This is where the difference between any CAD drawing and physical prints make a lot of difference. One of the difficulties, until a print is made, our job continues to be in some drawing units, which in the end we need to convert it into a printable form, and in print form the dimensions are picked from there and they are measured. Since this was made for the United States, and we now elsewhere in the world except the US, most of them we have all become Systems International or the matriculated metric dimensions, where a small problem happens here, especially in the case of our students who enter our colleges in this part of it. The scientific community has used MKS or CGS system, in that M stands for length, length is in meters, or you have centimeters. So, extensively centimeters is used in the case of our normal drawing which we use up to the high school level. You follow centimeters. Unfortunately, when it has come to engineering, the standard which is used is millimeters. So, it needs to a little bit of conscious effort to remember that everything should be in millimeters, not in centimeters. Occasionally it leads to confusion, but then we have to get used to it. And as we come down, next important thing is, you see here, very, very important, leading zero. That is, if something measures 5 millimeters, it is considered perfectly all right if you write 0.5 millimeters, because when you want to some way mention it, and the way the centering and all takes place and the way things are represented, and added to that is how occasionally they are all sorted, that 0 is required on the left side. Earlier the imperial system did not permit anything. If something is 1 inch, you call it 1 inch. If it is a 1 1/4 inch, you call it 1 1/4 inch. And US did use the decimal system, but they have got into decimal inch system. So, something will become 1.5, 1.5, and fractional inches are slowly getting what you call replaced. And by definition, if you do not include anything, you need to include this in the title block, saying all the dimensions are in millimeters unless otherwise specified. This, if you remember how we have various options. These options can be set easily in your CAD, or by hand when you do it, you can do these things. And when it comes to cylindrical dimensions, you see a small difference is there. While this could be a section view, half section view and all this, invariably these cylindrical parts are all mentioned with the diameter symbol. Only in rare cases the word dia is written, otherwise depending on the precision you require, 2 digits are all shown there. This looks like auto generated in some CAD package, since it is mentioned it is AutoCAD in the beginning, probably it is done like this. Next we come to how to mention angular dimensions. These angular dimensions are required depend on the particular type of job that we require. Sometimes, for example, this looks like a chamfer in a corner, or it could be a mating part. Say what they have written is the remaining portion, after you remove that, the remaining portion is mentioned here. This is actually it is inches, but let me continue to just call it 2.5 millimeters. So, I have 2.5 millimeters, 1 millimeter. This is mentioned and not the other way. You should not write this saying this is 1.5 and this is 1.5. Though while specifying chamfering, we probably specify those dimensions. So, dimensions, the remaining part it is easier to measure, check and all that. Setting is something else. Then in some conditions, angular dimension is preferred, and in some even other rare cases, if it is a taper, both the taper angle or the taper step is mentioned here, saying in this case both is 1.5 by 1.5, instead it will say 1:1 with the other dimension, saying how many millimeters down it is for a given length, which is another way of representing those things. So, you see here, coming back to the chamfers, it clearly says 45 degree chamfer, 45 into 3 at 2 places, 45 at this. This is a convention which is followed. Fortunately for us, that is those of us who are moving out to the new CAD and we make a solid model, probably even if you were to miss, the drawing can be read and the process people will be able to understand those things. Now, there are two other things here. There are two fillets here. This one is a fillet. Fillet is typically what you do for making sure that stress concentration does not occur. So, this could be part of a casting or it should be part of some other thing, an internal bore. So, see where the thing is shown. So, you have one thing where inside the dimension line, here it is brought out horizontally and it is shown outside. This is a matter of both convention in the company when you are working or the drafting office and the country where it is used. And similarly, it is also a convention related to where finally the trade in which these things are used. So, people who are in the construction field, they have different, people who are in the fabrication or chemical engineering fields, that different conventions they follow. You see, which is if you have a print, because you need a print when you are actually offering it in the fabrication shop. In the fabrication shop, see what they have shown, saying if there is a close detail we need to follow, we need to show it separately. Right now, for matter of convenience, only at that place the some critical dimensions have been shown here, otherwise the fit also is to be shown here, because this could be a circlip is placed inside, what is called an internal circlip. So, internal circlip has certain dimensions, that information also is required here. So, somebody needs to find out for every job how things fit together easily. Now, if you go back to the my slides again, length, width, height, position, dimension, size and position of each feature is defined only once. Very critical thing is why it is showing only once. If I change it in one place, automatically people have to refer to this and nowhere else, and two contradictory things should happen, because often whether you like it or not. So, and then this is a matter of convention, saying leave about this much dimension while printing and all that. So, you see here one very interesting thing, 2 millimeter is critical, 2.25 is critical and 6.25 is critical. This 2 is what is the remaining dimension. So, that it will not lead to any unnecessary confusion. Now, if you look at the right side, I have 1.5, then you see there is a small dot here. The dot represents from here to here. Now, are we violating it? Strictly not, but it is unavoidable here. You must show this. You can't leave this, otherwise it does not make sense. If you see here, this last portion from here to here is not mentioned. See here, this last portion from here to here is not mentioned. 1.5 is mentioned, total 3 is mentioned. So, by default it will become 1 millimeter. I suggest you go through this from the Department of Mechanic ME, I think 201 from Drexel. It is something which all of us and will be able to understand what these things are. So, these are all matter of convention, only when you come to a little. You have seen this very important thing. What has been shown there is, we have a, let us say I am representing this. When I am representing this, I may have dimension something which needs to be put from here to here, put from here to here. It is, except in very exceptional cases, we cannot use these two lines to show the dimension. It is always logical to bring it out and show it like that. And then you see here there is a small step here. Now, there is every chance of the small step being forgotten or ignored in case we try to follow these things here. Now, you see here at the various things about how dimensions are good grouping. You see here we are trying to dimension the center point of this. So, things related to this 0.63 and 0.88 have been shown which are related to that. Though technically it is possible that we can put it somewhere else, logically it is not correct. Similarly, if you see from the edge, this takes some 0.5 and 0.63 and there is a 0.5 inch hole. This is a very logical way. The same information is presented here, but if you see it is a little vague. If somebody wants to know where I drill this, logically 3.12 is shown here, similarly 1.25 is shown here, and it needs a little bit of thing saying I read 1.75 here, and then after that I do all this to just to locate this point. This leads to a lot of confusion and not easier way of doing it. Same thing here saying all sorts of mix up of things which are shown here. So, if you look at a part like this, we do not know what it is. You see here there is 5 here, obviously this 5 refers to this, see this, it is logical because somehow it leads to a wrong thing as if this the 5 millimeter belongs to this. If you now place it on top of it and make it logically easier for us to read all these things, two variants here, the groove width is given here and the starting point is given. In this case, from a datum line the things are shown here. So, both are correct, and logically if you place everything one after the other it will be easier to understand. In this case 2.25 has been given here and 1.25 has been taken there. While in principle this is correct, it leads to confusion. Same part if you have to be dimensioned like this, it will be very convenient for us to do these things. Do not worry too much about it, whichever package you have, usually these are common in this. So, I will stop this at this and continue with the next thing. These questions, that slide was intended for the people who are taking the drafting course in Drexel University, which is a one known very old extremely. Now, we have this important thing about surface roughness so far, which I have tried to avoid, which I will take separately because somehow it is very closely related to the type of fit that we are talking about. If something is smooth, the fits will be different. If something is, you need an interference fit, then the type of surface roughness we specify will all be very different. So, I will take a break here and we will get back to this later.